Please tell me you're on the way. I don't want to miss you once I've waved goodbye. So when you reach me, tell me you'll stay.
Hello and welcome on in, everybody. How are you doing? How are you doing after this fantastic long weekend? My name's Brian, and I'm here with some extended office hours as we move into April. So for those of you that are starting to prepare for your mathematics exams, if you have some questions and you do want to get those questions answered, now is the time to do it. We might have a couple of ads coming on in hot, just so you guys are aware. But yeah, the goal over the next couple weeks will be to stream a little bit more than I usually do. I usually do about twice a week, but we're going to try to up that up to at least 3 or 4 times per week in hopes that we can get you guys all prepped up for any of those exams that might be incoming here in the month of April. Now today for us is still the last, and this is still the last week of classes at the college that I teach at. But I assume that kind of as we start rolling through this, we'll probably start to get more and more questions. And I tried to pick a variety of times so we have a new updated schedule. We're doing a kind of 1 o'clock-ish start on Tuesdays, 3 on Wednesdays, 5 on Thursdays, and closer to 7 o'clock on Fridays. So it'll be kind of a little bit of a tiered effect here to try to kind of find a time frame that works well for all of the viewers as we move forward into our exam season. So I don't have any specific exam style questions from any viewers or students yet. So we will just continue on with the mathematics contest train today. So we've been working on, I think, question 5 from the 2019 Euclid contest. And what we'll do is we'll just kind of keep on trucking through that, try to maybe get through maybe 5 and 6 today, kind of see what people are up to, what they're doing. I feel like most people probably are in still like their food coma from the Easter weekend, but that's all right. What do we got here? 2019 Euclid is a 5B. Limes, hello. Yeah, I know, right? Man, 5A. That 5A was a trap, wasn't it? That was, so we did eventually get the answer to it, but yeah, 5A gave us a little bit of a, threw us for a little bit of a loop. So let's see if we can redeem ourselves with 5B here. Oh my gosh. I was reviewing that today. I was like, oh my gosh, what did we do last? Also, I apologize for like the several hundred untitled pages that I have. You can just ignore that. But yeah, how are you doing, man? How was your long weekend? So what do we got going here in 5B? So we have a system of equations. C plus D is 2000. C over D is K. Determine the number of integers K. The number of integers for which there's at least one pair of integers that is a solution to the system. So we need two integers to add up to 2000, but we need to take c and divide by d to get k? What? Oh, I see. It looks like, let's see. Interesting. Okay, give me a second here. I think it's my capture card has decided to freeze itself. Why is it suspended? What does that mean? Status suspended. Huh? Why are you suspending? What? What? Why did the capture card decide to just freeze? That's so bizarre. Why can't I force close this? That's the next best question. Let's see. What's the easiest way to do this? Why are computers so funny? So it was great food, family, all that good stuff. How was I had a super chill weekend. Like, I feel like I literally did nothing. I feel like we're gonna have to transition here. So let's transition into a break. As I deal with technical issues. Okay, so if OBS does not require 4K, can I end it? Can I end it now? I think that worked. Okay, so I think that killed 4K. And now the question is, can we bring it back from the dead? Come on, Elgato, you got this. Like, what did I do this weekend? I bought a shelving unit yesterday. That's exciting. I realized I didn't have enough shelving to, like, start all of the stuff that I needed to in the garden, so I, like, ran out, bought some more shelving, set all that up yesterday. Okay, 4K is being fussy. Okay, let's see. Does it still say suspended? That's the question. That is the question of the day. Okay, so it looks like it's working good there, so it's probably a connection problem. All right, and we cross our fingers and hope that 4K comes back. No captured, what? No captured devices found. What the fuck? Why are you being so fussy? You've been fine. I've literally been using I've been using Elgato all morning. I don't know what is happening. What is going on? Okay, that looks better. What in the heck? Okay, so we're back here. Let's see if we can get the capture screen back online. And okay, and we'll see how long it lasts for. Because usually, if I kind of have this stuff open and going for like an hour before the stream starts. Because every once in a while, the capture card decides to just, like, bust itself. I don't know why. It doesn't play nicely with Alienware. I have no idea why. But yeah, there's something with the Alienware desktop that I have with the capture card. They just, for some reason, they just don't like each other. But we're back. And I think we're ready to start thinking about 5B. Although I feel like the statement of this question is a little bit weird, isn't it? determine the number of integers k. Oh, I see. So we're just trying to find... So k could be any integer, I guess, right? So k has to be bigger than or equal to 0. Well, I mean, there's... there's definitely the trivial solution where c is 0 and d is 2000. So I guess we start kind of thinking about what are our possibilities, right? So I guess we could start... So for which there is at least one solution, one integer solution. So 0 works. There's at least one solution. So 1500, yeah, okay, so 1500, if d is 5, I think it's, we want it the other way around, right? Do we want the, oh no, you're right, we want the bigger one up top, right? Because we need k to be an integer. Yeah, so k equals 3 should have a solution as well. I guess the question is, like, we could have up to probably half of 2000. So how far do we go and where do we stop? Yeah, this morning I was recording videos for like a solution manual, and I was using the Elgato capture card and OBS to kind of record everything. But I've turned that off, so hopefully I just needed to capture my PC screen because I have no other way of writing mathematics other than using the laptop. But it's been fussy ever since I've had the system, so it's a lot less fussy than what it used to be, which is nice. So but still a little bit fussy. So I guess the question is, okay, so c divided by d. So c, I guess, for the most part, c should be probably bigger than... 0 is a special case though, right? So I feel like c should be bigger than d when we don't take 0. Because we want to be able to take c divided by d and get a whole number. And what's the biggest that we could make c? I guess the biggest that we could make c is 1999. That's going to give us k is equal to 1100 or 1999. Is that true? Like, could we take c to be 1999? We could add 1 to it to get 2000. And then I could take 1999 and divide by 1 to get 1999. That's so bizarre. So d divided by c. Oh, I see. So we could maybe think about... Yeah, we could think about... How does that work? We could think about d has to be a multiple of c. That's a good idea. Right, so if c divides d to get an integer, that implies that c must be a multiple of d. Oh, and if that's the case, then c plus d equaling to 2000, it must be that this is a multiple of d. Oh, cool. That's such a cool way to make this work. So if we factor out d, we'll have k plus 1 times d. So how does this work now? So d has to be a divisor of 2000? Does that make sense? All right, if C is a multiple of D and we're adding D to it to get to 2000, I think that D has to divide 2000. I think that has worked with all of our other stuffs. Right, D was 2000, D was 1, D was, I think you had 500. So I guess maybe we start with all of the divisors of 2000. I don't think 2000 can be divided by 3, right? Can it be divided by 4? Probably by 4. I feel like 4 makes sense. Hey, prime factorization. That's a good idea. What do we need here? We need 2 times 1,000. And 1,000 is 10 to the power of 3, right? So this will be 2 times 5 to the 3. So what do we have? 4 copies of 2 and 3 copies of 5. So we need 5 times 4. We're going to need 20. There's 20 factors. If we have 20 factor, obviously 1 is going to be the null case, but then we have 2, 4, 8, 16, 5. 5 times 5 is 25. 5 times 5 times 5 is 125. So those are all the single variable cases. Then we need all the cross cases. Okay, 2 times 5 is 10. 2 times 25 is 50. You can tell I still have a math hangover from the weekend. 2 times 125 is 250. So that's all of the single 2's. Then we can take 4 times 5. 4 times 5 is 20. 4 times 25 is 100. And 4 times 125 is what, 500? Then we go 8 times 5 is 40. 8 times 25 is 200. 8 times 125. What's 8 times 125? 1,000? Oh, and then the 16 times tables. Oof. I don't know if I know my 16 times tables that well. Okay, so 16 times 5 is 80. 16 times 25 should be, what, 400? Yeah. And then 16 times our 125 is going to be our 2,000. So it should be all of our factors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. Okay, so I'm going to nab these. We're going to move these up, and we're going to see how many of these actually work. What can we get rid of? We can probably get rid of this argument. We already know that D has to divide to 1,000, or 20, yeah, 2,000. So I guess here's where we start. We got to start with these divisors of 2,000. So the question is asking how many Ks are there? Yeah, because there could be other Ks. I have to be careful what I say. I think 0 is the only fringe case, isn't it? How does it work? We have K plus 1. I feel like 0 is the only fringe case. But what are we looking for? We're looking for a divisor D. So these are all of our possibilities for D here. We need a divisor D, and we need our K value to be, what, 1 less than the paired number, right? So for example, if D is equal to, what did we say? 500. If D is equal to 500, then K is equal to 3, right? Because it's 1 less than the paired divisor, which is 4. Oh, wait, what? K can't be -1. It has to be positive. So every pair we have, I feel like every pair we, for the 0 case, so you're saying for the 0 case, K is equal to -1. Yeah, that's what I'm saying. Yeah, so I think if K is 0, then you get the pair 2001. So I think the idea is like each one of these pairs is going to give us a possible value for K. Yeah, I think you got it there. Yeah. So it's not that K is -1. It's I think K is 0, and when K is 0, I get the pair 1 and 2000. Yeah. Kind of similar to the one you gave, which is, you know, if you take the pair 504, we should get 500 times, right? K is 3 because we need 504. So I maybe that means that every single pair, so for example, 2 and 1000 should give us K is equal to 1? Is that how this works? So I guess we just need to go through and start pairing these up. So 8 times what is equal to 2000? Is that 250? I'm not sure if I have enough ways to highlight stuff, but what's next? So we have 10 and 200 should be a pair. I guess there should be 10 pairs, right? So maybe there's 10 different values for K, 10 pairs. Yeah. Yeah, I can get behind that. If we have 20 factors, we should have 10 possible pairs. And I think since D has to be a divisor of 2000, I don't think we can get any other possible values for K. Yeah, I agree. I think there's only going to be 10 possible values here. Let's take a look. I'm kind of curious now. So let's see. From the second equation, we know that D can't be 0, right? Rearranging, we get a multiple of C, which is what we thought. Then substituting, yeah, sweet. So they kind of did the same thing as us. So they said K plus 1 times D should be 2000. Yep, so K plus 1 has to be a divisor. We know that D also has to be a divisor. So there's 20 positive divisors, they say. They've listed all of the 20 divisors. Then there are 20 values. Oh, 20 values of k for which the system of equations has at least one integer solution. Does it work in the opposite direction? I thought that C had to be bigger than D. So if we have... Let's see. Okay, so does the k... So let's look at k is equal to 3. And it should also be that k is equal to 499 if what they say is correct. Because k is always 1 less than the divisor that we're working with. But I think that maybe they fucked up with the c over d has to be equal to an integer. Maybe. Because I think c has to be bigger in order for this to work. So these are the two cases that I want to think about. If k is 3, then we're specifically looking at the kind of 4 times 500 case. If k is 3, we know that 4 times 500 is equal to 2,000. That's true. Unless I don't, unless I don't know what z is. Yeah, totally, right? I feel like it's got to be an integer. So this is d. And that would imply if d is 500, then c must be I see. Yeah, so c must be the bigger. So, that's interesting. Okay. That's interesting because I don't think it matters even if we pick k is equal to 499. I didn't really notice this, but if k is 499, we're going to get 500 times 4 for 2,000. This tells me that d is equal to 4. So that means that c is equal to 1,996. So c is always going to be bigger, 1,996 over 4, right? It's always going to... That's so bizarre. Yeah, that's so weird. So it doesn't really matter what value that we pick for d. C always ends up being bigger because of that addition equation we have. So that when we do the division, we do get k properly. Interesting. Okay, cool. That's really interesting. So if you're looking at the first case, when k is equal to 3, yeah, when k is equal to 3, k plus 1 should be 4, and it's the other number that's d, right? So I'm kind of going back to this formula up here. So we've chosen a value for k, which is 3. That means the multiplication we're looking at is 4 times 500, so d is 500. And when d is 500, we should be able to solve for c using the addition formula here. So 2,000 minus d is how we describe c, right? That's where you got your first pair. So c is bigger than d, therefore we can divide them and get k is equal to 3. Yeah, that's nuts. Okay, like I felt pretty good about it, but they threw me for a loop. Every single possible divisor of 2,000 should work. We were close. We had the right idea. Right, we had the right idea. I just didn't, I mean, I didn't go back and think about the two equations. I thought that, yeah, I thought that we needed to divide them in half, but we didn't. So that's really interesting. That's a cool little question, though. I really like that question. No! My arch nemesis. I don't know if I'm ready for this today. 2090, this is a 6A. Oh gosh, this looks just nasty too. Oh no. Apparently I need to go back and relearn number theory, which I'm supposed to teach this fall, which is great. Okay. Regular pentagon. A regular pentagon covers part of another regular polygon. The regular polygon has n sides, 5 of which are completely visible. In the diagram, the sum of the measures of the angles A and B is 88 degrees. Determine the value of n. Do you think we're going to... I'm wondering if we're going to need to know the degrees of the regular pentagon. Let's take 360 divided by 5. Okay, so all of those should be 72. The other thing I'm wondering is, the other thing I want to know is, does this keep going, or does it do this? Okay, we do need to use that somewhere. And all I really know is that the side length of this pentagon is a straight line. So what do we think? What do we think? Would this... It just says it covers part of a polygon. So I don't know, like, is that gonna go straight through? And if it does, sorry, I'm trying to use my ruler here. Or I guess it could go off in a different angle direction as well. I mean, I guess we could look at both cases. In both cases, we should be able to figure out the different angles. Both are regular polygons, that's correct. I mean, I guess we could just start cycling through all the possibilities for n that are bigger than 5. We could start with 6. But obviously 6 doesn't work because 5 edges are showing. So n has to be bigger than 6. It's probably going to be bigger than... What other regular n-gons? The lines are equal. Yes, the side lengths are all the same and all of the angles are the same. That is correct. I agree. I'm thinking it's probably going to have to be at least twice as big as what we have shown here, right? If not bigger. I just can't remember what regular n-gons we can create. Maybe that's something we should look up. So if we believe it's got to be bigger than 6, 8 is going to be the smallest one we can get. So 8, 10. Oh, these are just constructible, though. I guess all n-gons are probably... Okay, I take it back. All n-gons are probably exist. We just might not be able to construct them all. But I guess I'm wondering, like, if the angle, or like if the line keeps going straight through, then couldn't we just call this angle 180 minus b? And if it did something weird, such as deflecting off and not going straight through, you know, so if it decided to do something like this, then we could probably also figure out what this angle looks like. This is going to be 360 over n minus a degrees. So I think in either case we can probably figure out what the angle has to look like. I just don't know if that's helpful. And I don't know if knowing 72 degrees inside a regular pentagon is helpful. Yeah, so you're right. We could, yeah, we do need to use that somewhere too, right? We do know that 88 minus one of these things. So could we make a substitution and do something like 360 over n minus a? That's what that angle would be, right? I hate that when you have kind of like, when you think you have it, but it would be nice if it has n sides. 5. Oh, wait. This regular polygon has n sides, 5 of which are complete. Oh no, it says completely or partially visible. Oh, I thought it said completely visible. I'm like, damn, that'd be nice. Completely or partially, so we don't really know. I thought I was going to say which are completely visible, and I'm like, yes, we know exactly what these angles are. Yeah, that's not helpful. Because then we could just divide A and B by 2, and we're off to the races. Yeah, 4 different cases, and I guess that's possible, right? There's 4 different possibilities. Yeah, I guess so. I guess we could try starting there and see what happens. So we could start, I guess, with case 1. Case 1 is that, oops, is that both of them are partially visible, in which case up here we're going to have, what, 180 minus A, and down here we'll have 180 minus B. I'm not even sure how to start that particular case. Maybe let's do a case that makes sense. What if both of them were completely visible? So by both of them, I mean, what if both this side and this side were completely visible, so that basically our pentagon is intersecting directly at the bend, right where the bend would be. If that's the case, then each one of these, we should have 360 over n minus a, I guess, is going to be equal to 360 over n minus b, right? Both of these angles should be the same. And so we know that A is equal to B. So both are 44 degrees. If both A and B are 44 degrees, then we know that 360 over n, how does this work? 360 over n is the full angle, right? We need to subtract 44 degrees from it. Wait. Wait, what am I doing? What am I doing? Okay, so if they're this, okay, if they're both 44 degrees, I feel like this is just going to give us a contradiction. But what if, okay, so what if both of them are 44 degrees? Oh, then we know that 360 over n, we need to be able to subtract 44 degrees from that. So that'll probably give us some restrictions on the value of n that we can pick, right? So what values of n would work? So we need to be able to, so I think the idea here is we need to be able to subtract 44 degrees. How do I write this mathematically? We need 360 over n minus 44 to be bigger than or equal. We need it to be bigger than 0. So obviously n can't be 44 because I can't subtract 44 degrees from that. So for example, I know that n can't, if n was equal to 10, for example, 360 over 10 would be 36, and I can't subtract 44. It doesn't make any sense. So I think so what values of n actually make sense? What's 360 divided by 8? 360 over 8 is 45. So each one of these would be 1 degree. That doesn't make any sense. I guess it's technically possible. So, the best value of n we can get for case 2 is, n is equal to 8 or less for case 2, which I think just doesn't make any sense, does it? If there are 5 sides showing, I don't think we can we certainly can't make 6 or 7 work. I don't think we can make it work. So it has to be that one of them is partially visible and one of them, I think that's the way we got to go. I think we have to go that one of them we can kind of do this and keep going, and one of them has to be able to kind of tilt. It's probably B that's going to keep going, and it's probably A that's going to start tilting. And yeah, so case 3 and case 4 are going to be the same without loss of generality because of symmetry. Yeah, exactly. So case 2, I think we can rule out case 2. I don't think that makes any sense. So let's look at, I still don't know how to deal with case 1. Case 1 doesn't make any sense to me. But what if, let's just say without loss of generality, that green goes straight through and blue does not. So I think we can probably start similarly, right? If blue is completely visible, then we know that this angle is 360 over n, the full thing. And so our inner angle is 360 over n minus a. And our inner angle in here must be 180 minus b. And the other equation we have, 180 minus b, is that a plus b is equal to 88. So we have 3 unknowns. But I only have 1 equation, right? So how do we turn these, how do we turn some of this stuff into equations? And is it possible to use the 72 degrees to do this? Can 72 degrees help us? Oh, that is true, isn't it? Mystery angles definitely have to be less than 72 degrees. That is true. Is it possible to... So let's use your thinking for a second. So if we do take our 88 minus a, and we make a substitution, what is 180 minus 88? 92. So if we say that b is 88 minus a, then this angle must be 92 plus a. Wait, what is going on? That tells me that means a is 88. That doesn't make any sense. That does not make any sense. What? 92 plus a. How a can't be 88 degrees? That doesn't make any sense. What are you saying? Boom, use the fact. B plus A plus 92. B plus A plus, yeah, B plus A plus 92 would be 180 degrees, yes. That makes more sense. B plus A plus 92, yeah. But still, that does give a restriction to A and B. I mean, A and B do have to be less than 72. And do we have any other... Any other possible ways of moving forward here, though? What if we try to do a substitution here? So 360 over n minus A, which would be 88. And B. Not sure I see an easy way to move forward here. Other than just like guessing and checking. I mean, it is a light bulb question, which usually means the answer can be found in a very simplistic kind of fashion, and maybe we're just overthinking it. I mean, we could just try substituting in values for n, I guess. But I think you're still going to be, so if we need to be able to, let's get rid of some of this stuff. So just for fun, I mean, if we think that n is equal to 10, I just want to play around a little bit and see if there's an easy way to move forward. Otherwise, I'm going to take a peek at the answer because I'm kind of curious. If we just kind of start slapping in some values for n, like if n was 10, that angle would be 36 minus a. So a could be... But the thing is, that angle has to be bigger than a. So I can't take a all the way up to 36. I can only take a up to... Maybe it's twice as big as... up to like 12? Right? A could be something like 12? Because as soon as I start taking a up to 18, it just doesn't make any sense. Right, because the angle going out is at least twice as big as the angle coming in. So I think you're kind of restricted on values you can choose for a. So, you know, if we say that a has to be somewhere between 1 and 18, then what does that tell us about b? If a has to be somewhere between 1 and 18, then what are the bounds on b? So b would have to be somewhere between, if a was 1, the biggest b could be is 87, which would be fucking huge. And if a was 18, that means that b is going to have to be around 70. But so I think that a and b, like one of these has to be fairly big. Because that just doesn't make any sense. So like 10 doesn't even make any sense. I think it has to be even bigger than 10. So let's see, what are we saying here? So am I wrong? So won't our mystery angle be greater than 72? 72 is, oh, have they drawn this? 1, 2, 3, 4, 5. What's going on in this pentagon then? Am I doing my math incorrectly? Okay, so for a regular n, maybe it's just me doing my math poorly. So a regular n-gon sum of angles. Maybe it's 720. Maybe it's not 360. The sum of interior angles of a regular n-gon. Oh, it's different. Okay, so it depends on the number of... Really? Then the sum of all of its inner angles is n minus 2 times 180. Does that make sense? That would definitely affect the way that I'm thinking about this problem. Yeah, here it is. Interior angle and central angle. So a regular n-gon has equal interior angles. Since there are n of them, and given that the total sum is n minus 2 over pi. Okay, so n minus 2 times pi is 180. So n minus 2 times 180. Okay. So I got that wrong. I am way off. No wonder why numbers were coming out a bit funky. Okay, back to the drawing board. Back to the drawing board. What if they are both partially visible? We need to take n minus 2 times 180 degrees and then divide by n. That's going to be the angle at every possible occurrence. That means that this 72 is incorrect because we're going to take 5 minus 2, which is 3, multiplied by 180, we get 540, and then we're going to need to divide that by 5. So each of these is actually 108 degrees.
Time for a pop quiz.
So I'm just hanging tight for a second here just to let some of the ads roll through. But yeah, my intuition says that these must, I mean, looking at them, they have to be bigger than 90 degrees. Yeah, I didn't know that either. I thought that it was a 360 thing. But that must be when you're looking at the middle, right? When you're looking at the middle and you're doing something like this, those angles must be 360 divided by n. So I was thinking about the inside angles rather than the angles along the outside. Oh, sure, yeah. Yeah, call me on my bluff, it's okay. But yeah, I think so for the pentagon, these have to be 108 degrees, and that makes sense looking at the diagram a little bit more. So the formula that we need to work with is n minus 2 times 180 over n. Well, let's just get rid of the degrees. I don't really need that. So each of these, and so all we know is we know that a plus b should be 88. So if both are partially visible, can we conclude anything if they're both partially visible? Yeah, I don't think that is helpful. So case 1, unknown. I'm not really sure how to move forward with that one, but I think we can probably go back to the case where both of them changed direction a little bit. So if we look at that case, we can conclude that A and B have the same degree. Both of them are 44. And each one of these angles should be n minus 2 times 180 over n. So if we choose a value for n, we need to be able to subtract 44 from it, right? So each one of these angles is going to be this number. So I think this particular case is just going to give us a lower bound on what n can be, right? So for example, if we try to choose n is equal to 6, we'll get 8 times 180 over 6. And I think we'll probably find that that just doesn't make any sense. It's 180 times 8 is 6. That's interesting. We can actually start to find some of these inner angles. What? What? Oh, but there's... How does this work? This must be... I agree with you. I think this is going to be a dead case. I think this isn't going to work. Because if n is equal to 6... If n is equal to 6, what do those... So 4 times 180 divided by 6. Each one of the inner angles is... Oh, wait. I did this wrong. I went to 8 instead of going to 4. Each of these would be 76. Yeah, I don't know why I put 8 there, but I mean, obviously it doesn't really make any sense. I mean, even if you go back and look at it, it just doesn't make any sense. I don't know. I feel like I'm really struggling on how to think about this question, though. And yeah, exactly. If it was, it wouldn't even work, right? Because we know that this would have to be connected for it to be a sixagon. So having a degree of 76 is way too big. I was just hoping that some kind of contradiction would make itself shown, because sometimes when you can figure out what those contradictions are, you can use them in some of your other arguments. But I just don't see an easy way to make contradictions. That's all. Like, there must be a way that we can make contradictions. Yeah, I just don't know what that looks like. I'm actually really curious. I'm gonna go look at the solutions, because I do have to probably run here in a few minutes. But I'm really curious now to know. They have more than one solution. Interesting. Okay, so the angles in a polygon with n sides have a sum of n minus 2 times 180. That's correct, yes. This means that the angles in a pentagon have a sum of 540, yep, which means each interior angle of a pentagon is 108, which I think we have, right? 108, yep. Also, each interior angle in a regular polygon with n sides has this, right? So this is the formula that we found after a little bit of sleuthing, and then they consider the portion of the regular polygon with n sides that lies outside the pentagon and join the points like so. This polygon has 6 sides. 1, 2, 3, 4, 5, 6. And so it's 6 angles. Okay, I'm going to stop here. The sum of its 6 angles is 4 times 180 degrees. I think knowing this part of the solution, we should probably be able to solve the question. I feel like knowing this, right, that we were kind of off to the right track, we just needed to focus our attention in on this particular area. Maybe now we can start creating some equations. We know, for example, one that will relate A and B. We know how to find some of these other angles, so I think we can now start making some equations and trying to solve this. So yeah, I agree with you. I think we did some good groundwork. I think with the groundwork that we did, we should be able to finish off this question. But that's not for today. I'll probably come back on Wednesday. I'll probably come back tomorrow. 3 o'clock is what I'm thinking for tomorrow afternoon. And I think with knowing this, we should be able to push our solution forward. So C and D, is it 108 divided by 2? That's a good question. Is that line necessarily going to bisect? That is a good question. Does that line bisect? Not necessarily. I don't think it necessarily has to. Right, because we're kind of like, my line is bad, but we're kind of more up here, right? So yeah, it doesn't necessarily have to bisect 108. But, yeah, we don't even know the side lengths, do we? All we know is that this little angle inside of here is going to be 108. If that's even helpful. And yeah, I guess part of the problem too is we don't know whether or not C and D are going to have the same angle measurement. They may not. But we do know that that inner angle is 180 degrees. So if we do label this as C and we label this as D, then we know that 108 plus angle C plus angle D should be 180 degrees. So we do at least have an equation that we can relate C and D with. So I think that might be kind of the way to move forward. We can start maybe crafting up some equations, and hopefully we get enough equations inside of the unknowns that we're looking for that we can solve for n. So I'm going to leave it there for today, I think. And we'll come back and we'll revisit this question. This is a good question. I really like this question a lot. So we will revisit this question tomorrow afternoon at 3. And as always, if you guys have some other mathematical questions that you want answered as you're preparing for your final exams, drop in tomorrow 3 o'clock and we can get those questions answered. Yeah, I'll leave it with you, Loims. Yeah, think about it. And come prepared tomorrow. I'll think about it a little bit and see if I can come prepared tomorrow too. I think I have a good idea of how to get it going. I think I have a good idea now. All right, so I'll see you guys tomorrow. Thanks for hanging out, and talk to you soon.